Yeah. I'm all caught up except for like a day.
Weren't you supposed to be caught up by today?
That's completely different. He's talking about videos.
Oh.
Okay. All right. Ionic bonds. Quickly, raise your hand. Tell me something you know about ionic bonds.
No, it's giving and taking.
Giving and taking electrons.
They're ionic.
Duh.
They're between a metal and a
They're between the metal and non-metal. Anything else you could say?
They have it.
Yeah?
Like one element has more electronegativity, so electron bonds go towards one down.
Creating
polarity.
polarity. In fact, we call ionic bonding complete giving and taking, so it isn't partially charged, it is completely charged. Okay? That's why ionic bonds are held a lot tighter than covalent bonds. Okay? We'll get into that though. So this is all review here. Just need to make sure that we re-solidify this and make sure that we know well what makes an ionic bond. So really this last test that you just took was kind of the big overview of the types of bonds, but then it really focused on what type of bond. Yeah, it was predominantly focused on covalent bonds. Okay, in this second half of the chapter, we're going to primarily focus on ionic bonds. Does that mean we're not going to ever talk about metallic or covalent at all? We still need to know, you're still going to need to know on the next test how to identify them. Okay, any new information up here?
No.
Okay, ionic bonds form when what bonds? Metal and a non-metal. Okay, we all know here metals are located where?
On the left side.
Left side of the stair step. Non-metals are located
On the right side.
right side of the stair step, and metalloids are
Adjacent.
adjacent to the stair step. And there are two exceptions. What are those two exceptions?
Aluminum and germanium and
Aluminum and
tin.
hydrogen.
Oh.
Aluminum and hydrogen.
Okay. Why is hydrogen an exception? Muchacho?
Because although it's over there, it's supposed to be over there.
What does that mean?
It's alone.
It's not metal.
Thank you, Shane.
You're welcome.
Yeah.
But it only has one.
Ow. Ow.
You're right. Okay? Yes.
So if it only needs one to be stable, if it loses one, would it still be unstable?
Because there isn't any, it doesn't have an energy level that it can drop. Does that make
So
sense?
then it would be just nothing.
No, it would just be a lone proton. And probably a neutron. But most hydrogen isotopes do not have neutrons, believe it or not.
So it's just a proton.
Yeah, most hydrogen atoms are just one proton and one electron. So if you took the electron away, you just have a lone proton.
So then
Most hydrogen atoms don't have neutrons.
So then
There are a few isotopes that do, but what?
So then what would happen to the proton?
It would float in space.
Nothing would happen.
Depends on the situation based. Happens a lot in acids. Gives off a proton, a hydrogen ion. Nope, that's higher level, quite a bit later. Okay? Okay, let's keep going. Going back to that electronegativity word, what? Hey, what's nice about what we're doing today is it's kind of review. Right? Metals have high or low electronegativities?
Low.
Low. And the nonmetals tend to have high electronegativity values. That's normal, right? Nothing new. So if one really wants and the other doesn't really want, what's going to happen?
It'll come forced. Or
Yeah.
yeah.
What?
Yeah.
Yeah. Huh?
The one that's higher electronegativity will take the other one, and the other one's just like, okay.
Okay. You have it. Yep. That's what you were going to say, right?
Yep. Just drop
Look
it.
at doctor
Never
though.
gonna happen.
Such a disappointment.
Keep reminding you every single day.
Eventually, by the end of the year, we'll see.
We'll just throw pennies and dimes.
That's really what I just make people believe that I can change it to gold, that you can start giving me pennies and dimes, and that's how I make my money. Okay, let me quickly review. Remember there was a trend for electronegativity, right? Where was the least electronegative element?
Oh,
Francium.
Francium, down here.
Yeah.
And the most electronegative was?
Fluorine.
Fluorine. So the trend is really bottom left, top right. Well, look what's in the top right. The what?
Yes.
Seven
Metal.
Metals, and in the bottom left are?
Metal.
The metals. Okay, so that should be, again, review for us, that when we're talking about the metal has a low electronegativity value, and when we're talking about the non-metal, we're talking about a high electronegativity value. What that simply means is, something that has a high electronegativity value, what, can someone put that in layman's terms for me? Like what high electronegativity? That seems like a lot of, a big mouthful of concept.
It wants electrons.
You want, yeah, it's a strong pull of electrons. Okay? And it should make sense. How many valence electrons does fluorine have?
One.
7. So, is it close to getting an octet or not?
Yes.
Yeah, only needs 1. Versus if it were to lose, it would have to lose how many?
7.
7. So, it's going to want those electrons, so it's going to, most of the time, take if it's bonded with a metal. Okay? So as a result, the metal will lose its electron. Let me show you again. I've showed you this before, but let me show you again how this works. Just a quick little review for all of us. First energy level can be filled with how many?
2. 8.
Okay? You okay?
Oh,
Okay. I thought you were like choking there for a second. Oh my God, I gotta save a life! Okay, so there's your first 2 electrons. Next, second energy level can have how many?
8.
Okay. So 1, 2, 3, 4, 5, 6, 7, 8. So how many total have I accounted for?
10.
10. How many does sodium have?
Sodium.
11.
Yeah.
Which means I need 1 more. Where's that 1 more gonna go?
Shell.
Ah, okay, so would it agree that its outer energy level has how many electrons?
One.
One, and that's the definition of what a valence electron is. Outer energy level electrons.
Right.
Okay? So,
Okay.
sodium has one valence electron, a lot more difficult to gain 7 than it is to lose 1. So if it loses 1, now what is its outer energy level considered?
Stable.
This is no longer the outer energy level, is it?
No.
It doesn't have any electrons in it. So this is the outer energy level. How many does it have?
8.
8, and that fulfills the
Octet rule.
octet rule.
So it acts like neon. You're welcome.
Good job.
Thank you.
Whoops. This is just kind of stating what I've already just been talking about, but get it in your notes here. Just in case you just have a brain fart right before the test, and when you study, you finally realize, oh yeah. Your notes one last time. Now let's say I'm talking about fluorine. How many regular total electrons does fluorine have? It has 9. Okay, so 2 in the first and 7 in the second, making it have 7 outer electrons and therefore 7 valence electrons, correct?
Correct.
Let's say it bonds with sodium,
Right.
which doesn't want that 1 electron, and fluorine takes it, and voila! Now, how many electrons does its outer energy level have?
8.
8, and it fulfills the
Stable.
octet rule, making it
Bless you.
stable. Okay, stable. And what does stable mean from an energy standpoint?
Low energy.
Low energy.
Amen.
As an ion bond forms, when 2 oppositely charged ions are going to be created when 1 gives an electron and 1 takes. Okay, so we've been talking about sodium and fluorine, right? Okay, we said sodium has a low electronegativity value, so it wants to what? Give. Fluorine has a high electronegativity value, so it wants to take, and so we got, voila. What that does is it creates ions. Do you remember the two types of ions there are?
Cation, anion.
Which one is the cation here?
Sodium.
That means it's
Oh, wait,
positive.
wait, no.
It has to be positive.
Okay. Why is sodium the cation?
Because it's positively charged because it has more protons than it does electrons.
Yes. So sodium is going to be the cation, or the positively
You should have put PAW.
It's-
I can't spell.
It's an E instead of an I on the last one.
That's fine.
That kind of looks like an R.
You know what?
Positive.
You want me to start saying what you kind of look like?
Very full of shade of surface space.
Okay, so cation is the positively charged guy. Now the question is, why is sodium positively charged?
It has more protons than electrons.
And why does it have more protons than electrons?
It's got 11
It
protons.
got rid of an electron. So for example, if we're talking about neutral sodium, how many protons and electrons does it have? 11 each, right?
Yeah.
11 protons, 11 electrons. If I lose an electron, now I have 10 electrons and 11 protons, so it becomes positively charged.
So the lower electron.
So it would be Na plus. Okay? And then by default then, since we know this is the cation, this is then the, yeah.
So the one with the lower electronegativity is the positive one?
So what happens is the anion, or the fluorine becomes, the anion becomes negatively charged. So we got an Na plus and an F minus. And what does a positive thing and a negative thing do to each other? So these oppositely charged ions here attract, forming our ionic bond. Move. Sorry. Okay, ionic bonds formed between, easy one.
2.
I need to have everyone not talk so that you have a chance to process.
Oh.
Okay, don't say process. Mari, what do you think?
Okay, so the question is, what happens to outer electrons? Can I say electrons?
Sure.
Electrons in ionic bond. So the metal ion. So it's I just said it in my head. That one there.
Which one?
This one.
3. Okay, yeah. Yes. Yeah. Don't put this in your notes. I feel like I've already explained this, right?
Yes.
Sodium has 1, fluorine has 7. If sodium loses an electron, it would satisfy the need electrons in the next lower level. Fluorine would be happy. Yes. Yes.
So then the electron that was given over would be found in fluorine.
Yep.
Alright. Thank you.
So kind of like this. Oh, that's technology right there, and it's minus. You didn't see it?
No.
Now look it. Sodium is what?
Quality and
Sodium has got what in its own energy level?
0.
hold the
8.
Well, you were
This
pointing.
is no.
Yeah, you
Okay,
were.
and it's positively charged. Now this has 8. It's negatively charged, and then those things go smack. Attractamunio.
Hold the phone. Why is that one electron that got to move? Why is he lime green? You know.
Stop, man. We're done.
Yeah.
Oh,
Silent ball, please. Silent ball, please. Silent ball.
Homework.
Yes.
No.
Well, no, make it all the way up. One last question in my homework.
Wait.